Hello and welcome back to the channel. In this video, we're going to be starting a new playlist where we're going to discuss the fundamentals of deep learning. We're going to start from the very basics and we're going to go to more advanced concepts as we move along through the course. So before we get into deep learning, there's other more general terms we need to look at. The first term is going to be artificial intelligence. So basically, artificial intelligence is a catch-all term, and it's used to represent any system that uses information to make decisions or predictions. And the main point here is that it does this without human involvement. So the term artificial intelligence is usually used interchangeably with machine learning, but they do have their differences. So if we have AI, we can have different types of artificial intelligence. For example, one type is a rule-based artificial intelligence. So in this case, we're going to have a set of predefined rules, and based on those rules, without human interaction, the artificial intelligence can make decisions. For example, if we take an AI system that is used to detect spam emails, if it's using a rule-based approach, we would have a list of rules or conditions. For example, we might have, if it contains the word free, another rule might be if it contains the word money, or if it contains the word price. And based on these rules, we're going to detect if an email is spam or not. So this is a rule-based system. Another type of artificial intelligence we can have is one that uses machine learning. So if it uses machine learning, instead of having a predefined set of rules, we're going to give the system a bunch of spam emails. And from those emails, our system is going to learn what a spam email looks like. So the next time an email comes, it's going to use what it learned before to detect if it's a spam email or not. So that is the difference between the two terms. So now we can give machine learning a more formal definition. So machine learning is a subset of artificial intelligence, and it focuses on algorithms, and it's used to learn from some training data, and it's going to use that knowledge it gets to make inferences or predictions about a new set of data. So now that we've defined the more general terms, we can go back to deep learning. So deep learning is a subset of machine learning, and what makes it different is for the learning process, it's going to use something called a neural network. So a neural network basically has multiple layers, and based on the outcome we get from our prediction, we're going to adjust the weight that one of the layers has in our prediction. So to summarize what we've seen so far, the most general term we saw was artificial intelligence, and a subset of that is machine learning, and a subset of machine learning is deep learning, which is going to be the focus of our course. There are different types of machine learning algorithms. The first one we're going to see is supervised learning. So basically how this algorithm works is we're going to have a bunch of input, which we already know what the output is, and we're going to use that to learn. And later on, if we get a similar input, we're going to use our knowledge to predict an unknown output. So let's look at an example. So let's say we have one input and one output. So our input is going to be Monday's stock prices, and our output is going to be Tuesday's stock prices. So these are going to be our inputs and our known outputs. For example, we might have $1, and at Tuesday it became 2. And on another Monday, it was $2 and it went down back to 1. On a third day, it was $3 and it went up to 5. So basically, this is our input and this is our known output. So our algorithm is going to learn from these data sets. And the next time we give it a Monday stock price, let's say of 6, then it's going to use what it's learned to predict Tuesday's stock price. So in this case, Monday's stock price is going to be our input, and Tuesday's stock price is going to be our unknown output, which we're going to predict. So this is how supervised learning algorithms work. The second type of algorithm is unsupervised learning. This type of algorithm is going to take in inputs and it's going to put them in cluster labels or categories. So let's look at an example. Let's say we have the following inputs: puppies, kittens, pizza, hot dogs, and burgers. So what our algorithm is going to do is it's going to give each input a label. So for puppies, it's going to give it 1. For kittens, it's going to give it 1. For pizza, it's going to give it 2. For hot dogs, also 2. And for burgers, also 2. So what this basically means is we're going to group similar data sets together. So let's say 1 might represent animals and 2 might represent foods. But one thing to note here is that our algorithm is only going to give us a number. So our algorithm is not aware that 1 represents animals. It only knows that puppies and kittens are part of the same cluster. Similarly, pizza, hot dogs, and burgers are also part of their own cluster. So this is how unsupervised learning algorithms work. The third type of learning algorithm is parametric learning. So this type of algorithm is going to learn through the process of trial and error. And we're going to see what this looks like using an example. But before we go to the example, we can actually combine the different types of machine learning algorithms we've seen so far. The first combination is supervised parametric learning. So this type of learning is going to use inputs with known outputs, which is going to make it supervised. And it's also going to use a trial and error approach, which makes it parametric. So let's look at an example. So let's say we have 3 different factors that affect the outcome of a football match. So the first factor we're going to have is the number of toes each player has. The second factor is going to be the win-loss ratio. And the third factor is going to be whether they're at home or they're away. So initially, we're going to have some random configuration of these different factors. And based on this configuration, our algorithm is going to calculate a prediction on whether the team is going to win the match or not. So let's say the prediction it made was 98% that the team would win. And when the results came, they actually lost. So the actual value the algorithm should have gave us is 0%. So from this, our algorithm is going to check which factor it used the most to calculate this prediction. In our case, we used a lot of the number of toes. So since we made a wrong prediction, our algorithm is going to decrease the weight of this factor. So by decreasing the weight, we're essentially using less of this factor when we make our prediction. Additionally, our algorithm also saw that win-loss ratio had more impact on the actual outcome. So it's going to increase the weight of this factor. And for the home/away advantage, it really didn't have an effect on the outcome, so it doesn't adjust the weight. So once our algorithm has adjusted the weights, it's going to make another prediction. So let's say this time it predicted 65% that the team is going to win. And again, the team lost. So our algorithm is going to see from the actual outcome that the number of toes wasn't a good indicator of the outcome. So it's going to decrease the weight of this factor. And it's going to see that win-loss ratio had, again, more impact. So it's going to increase it. And this time, the home/away advantage also had some impact. So it's going to decrease it. And similarly, it's going to make predictions again, and it's going to make adjustments to the weights. So to summarize the supervised parametric learning algorithm, we called it parametric because we have inputs and known outputs. And we called it parametric because we were using trial and error to get the right amount of weight for each factor. Additionally, when we say parametric, we're saying that we have a number of predefined parameters, which in our case is going to be the number of toes, win-loss ratio, and home and away. So we have a set of predefined parameters before we start our prediction. The other combination we can have is unsupervised parametric learning. Again, we're going to use trial and error, similar to the previous algorithm, but in this case, it's going to group the data instead of making a prediction. So let's look at an example. So as we said, this algorithm is going to group our data set. So we're going to have 3 groups here, and they're going to have some sort of configuration for the different factors. So for example, group 1 might have a large weight for the number of fans and a lower one for home/away. Group 2 might have a lower weight for the number of fans and a higher weight for home/away, and group 3 might be in the middle. So for the algorithm, we're going to have a data set that comes, and let's say it has 5 million fans and it's playing at home. So our algorithm is going to take this data set and it's going to place it in a group that matches the data the most. So 5 million is a relatively low number of fans, and since they're playing at home, they're going to have a high home/away advantage. So in this case, it's going to place this data set in group 2. Similarly, if we had another data set, and this time it had 30 million fans, and it was playing away, our algorithm is going to take this data set and it's going to place it in group 1. So that is basically how unsupervised parametric learning works. We're going to give it a data set and it's going to put it in a group that matches the information the most. The final type of machine learning algorithm we're going to look at is non-parametric learning. So this type of algorithm basically learns through the process of counting. So let's look at an example to see what that means. So let's say we have a restaurant that tracks whether a customer orders dessert after different meals. So for example, after pasta, 9 out of 10 customers order dessert. And for a different meal like salad, only 2 out of 10 customers order dessert. And finally, after steak, 6 out of 10 customers order dessert. So basically how the algorithm is going to work is it's going to count the number of customers that have ordered dessert after each meal. So in this case, there's a high number of customers that order dessert after eating pasta, and there's a low one after eating salad. So our algorithm is basically going to have pasta. So if the customer eats pasta, it's going to recommend that they have dessert. And in the case that they eat salad, it's not going to make the recommendation. So when we say non-parametric, it also means that the number of parameters we have is not predefined. So it's going to be based on the number of things that we're currently tracking. So in our case, we have 3 things. So we have 3 parameters. So if we had another meal, for example, we would have a 4th parameter. Now that we've seen the different types of learning algorithms, you can put in the comments below what type of algorithm you think deep learning is. So that is going to be it for this video. In the next video, we're going to discuss the different installations that you need to make moving forward for this course. And we're also going to be building our first neural network. Thank you for watching this video, and don't forget to like the video and subscribe to our channel for more programming content.